Hi, welcome to Scholarly, Academic Data Visualization and Analysis. For a little intro on our data set, these are the extracted relationships from the DBLP dataset. This slide shows the size of our current dataset. Next, we have our setup. The way our application is structured, we have the analytics engine in Python sitting with a Flask web framework communicating with our Neo4j database using py2neo, and on the client side for visualizations we use D3JS. And let's go to our site. This is our main page, Scholarly Cat. We'll run some clustering first. As you can see, we can limit the results. We can refine by keyword, and we can cluster based on authors and papers and using two distinct algorithms, multi-level and edge between this. So let's try 1000 for papers clustering multi-level algorithm. So as you can see, this is the clustering of our data set. The different colors represent different groups. And you can click on a specific cluster and zoom in, and you can get the information here on the paper title for that node I just clicked, and you can reference the cluster and get all the papers that belong to that cluster. And if you click on the paper title, it'll send you to DBLP, where it searches and returns the result for that paper. Next, I have preloaded here the authors cluster using multi-level algorithm, and as you can see, it works similarly as the papers clusters. We also have an analytics section where we return the top n results from 4 different categories: references, authors, institute, and keywords. I've preloaded these as the queries can take some time depending on the number of results. So here we have the authors, top 25 authors. You can see for these we've chosen a bubble graph where the size of the bubble represents the number of publications, and the position around this spiral is the position of the author according to publications. Here we have the institutes. The biggest institute is IEEE. And next we have the top reference papers. And finally, we have the top 100 keywords. Here, the larger the words and the more the lighter they are, the more they show up. So we can see here security, genetic algorithms, data mining, simulation, clustering, scheduling, etc. are the most used keywords, and the other ones are less used. And that's it. Thanks.